On the original ignition, dual point, this came out in, I do believe, 1966. It was the year after I went to school, and for the first time down in Rhode Island. And instead of having dual coil, dual point, they used these, they tied these two together so they just gave an impulse to the capacitive, the battery charged capacitor. And you could see there's only one, there's one contact back here, and both leads went to that one and triggered this thing to discharge the capacitor. And it went into the distributor, which was, I had the rotor is still rotating, and the distributor is distributing the spark. So the spark sent back to the distributor after it is triggered. And this was the coil for the for the dual point CDI ignition. So it was partly mechanical and partly solid state, supposedly. The horseshoe type ended up using this smaller coil. But the system, let's say, originally had one contact back here, and then the later ones, the horseshoe type distributor and the latest one that we're dealing with, had 3 contacts back here. The later one, which was all solid state, this incorporated the pass plate, and if you look inside of here, you can see there is a horseshoe-like module. This plate comes off, and you can, the module itself had the Hall effect sensor in it. Here's the plate right here. And of course, this again is the one we're looking at now. It's right here. There's the Hall effect sensor and the pass plate. These right here, other than rotting wires, worked very, very well. We had absolutely no problems with them. And this system right here, well, it was semi-mechanical, so you had to set the points. It had a special Thunderbolt ignition. This right here was the one for dual coil, dual point, breaker point, dwell and synchronizing plate. And this one right here, you can see it says Thunderbolt ignition. That was for the early dual point capacitive discharge ignition. So we're going to continue to put the this back together again. We talk a little bit about the capacitive discharge. Distributors. These are basically what Mercury called the triggers, and they use this from basically 1967 in one form or another till the late 70s, 79. I think was the last one to use it. 6-cylinder in the line, 90 horsepower. And they are, the early ones are fairly easy to diagnose because they work. In 1976, 75, 76, we started to see some in 75 that were probably problematical. They looked like this right here. If you look around, they had nothing, no markings here, and they were looked similar to the ones earlier. Ones seemed to work pretty good. The stuff that's earlier, no problems. And after a while, they discovered that, well, they really weren't going to fix very well. They came out with a new style one, an epoxy dot. We had a tester that supposedly could test these things. Yeah, they tested part of them, but not all of them. This was it, a Thunderbolt analyzer. Had a fairly complicated, well, I guess you call it a voltmeter, VOAC meter. Then it had the ignition analyzer right here. And had some modules that you plugged into it. This is a direct voltage adapter. This was the unit you used for the newer ADI ignitions. You used it with the voltmeter right here. Plug it in, and now you had a direct voltage adapter for it. It later came out with a different rig, a newer rig. And this was the thing to test the speed of these triggers right here. And here was another adapter. I really can't remember exactly what this was. A PVM meter adapter. I'm not sure what that worked for. And then you had a massive amount of connection wires, red, green. Some of them are missing out of here. And you hooked them up, wired everything up, got everything set up, get it working, and then as far as the trigger was concerned, it didn't work. So they finally fixed the trigger, like I say, with epoxy dots. The horseshoe triggers, in the earlier ones like this, you know, really their only problem is the wires just rot off. The wiring insulation is pretty crappy. So today what we're going to do is we're going to show you how to pull apart one of these things, what you have to do in order to change the trigger. This one right here is for CDI. It's a little different. We will cover the differences between it and Mercury's available, and it does work differently, and there are some parts you've got to change, even though they look like you don't. This one right here, if you're going to change the trigger, basically you have to take it apart, and you have some parts you ruin. First thing is there are little tab washers right here and right here, and you need to bend those down. So you bend them down by prying against the housing like this, and you twist it, and when they're far enough spaced, you then can unscrew it. Unscrew the cap. This piece holds the whole works together. There's the little tab washers right there. Here's the spring to hold the tab washers up into the indentations. And there's a washer right here because this whole part here swivels. Doesn't look like it on this one much. It's pretty stiff, but you can see that it does turn. And then the upper part turns on the lower part, which is pretty well gummed up on this one. So anyhow, the next step is to pull this apart. You can see the spring right here is sitting on a peg, and as you'll see as it comes up, it works its way down. There we go. Okay. And there we go. There's that piece. We don't need to look at those for a while. And we have, still have our rotor, and we still have it stuck in here. So now the next thing to do is, you can see these slot holes, you have to put screwdrivers in there and pry the top bearing out. And in doing so, you usually ruin it. So whenever you order a new trigger, you want to make sure you order a new bearing as well. You're in LA, so you have to go and find a bearing company, take the numbers off the one that comes out, and go from there. Now I've got them in the top slots. I'm ready to pry it off the rest of the way. Don't ever hit the top of this. It makes it very difficult to take this off. Now if you look, you'll see that I've ruined the seal, the bearing, the cover that goes over the bearing itself. I've had it in and out twice just so you can show you this, but you ruin it when you use the screwdrivers on it, so you have to replace it. Some guys can do it. I've never been able to. Okay, the next thing we got to do is we got a nut right here. So we want to have a deep socket. Three-quarters of an inch, three-quarter socket, and you can usually get on it. I typically have to put it in the vise. If you don't have a deep socket that's easily available, which I don't have right at the moment. And the next part is very, very important. I use a pair of water pump pliers, put a piece of cardboard around the porcelain, whatever this stuff is, Bakelite plastic, because it very easily breaks. I'll show you what you gotta watch out for. Okay, so I grab onto the back end of it, and be really careful and gentle. Take your time. Do not grab on the plastic. You unscrew the nut. There's a nut right here. We're taking this apart. You've got the nut out. Now we want to mark this plate, this pass plate, with up. That way we'll know how to put it back together again. So we mark it with up, we scratch it in. If you can't see it up, they put a stamp on there, but sometimes they're really hard to read. And now we hold on to the plate with our fingers and tap this with a plastic mallet, not a metal mallet, because you'll mushroom the end and you won't be able to get the thing back together again through that bearing. So here we go. Now we've got the plate marked up. And as you see, there are little gaps. On some of them there'll be two gaps. One of them is for the 4-cylinder, one of them is for the 6-cylinder. And so that's, you want to be something fairly careful. Now in here, we have one more bearing to get out. In here, it's the bottom bearing. They don't usually go bad, but if it's been underwater or something like that, you want to make sure you get that out. Okay, so here we are taking this bearing out. A pair of internal snap ring pliers. And then this one you can knock out. And there's the bottom bearing. Some of them had shims. You do have to shim out the clearance on this pretty rarely. The clearance between the Hall effect sensor. What this plate does is it disturbs the continuity between the upper and lower parts of the of this pickup here, and that's really the whole guts of this thing. There's some more circuitry in here, but that's what that does. Now, the Hall effect sensor in the CDI unit works differently. So you never want to use the pass plate out of one. If you look, no magnetism. This is the CDI plate, and it's very magnetic, so it's got a little bit different sensor in it. So you want to make sure that you use the right plate with this one. But other than that, it goes together pretty much the same way. All right, now we'll drive out. One last thing we've got to do to this one is we got to drive out the spring and probably take off our ground wire. So, whenever you're working on these things, though, you want to be very careful with this, because as you can see, it's not what you call really robust. You could push down this end and break it, and it's done. You can't fix it. Okay, so I'm going to get this thing out. Okay, now